In this case, we are interested in the calculation of current in the 10 ohm resistance using this method. That is Norton's theorem. Now here in this case, this is the point A and this is the point B, and we are interested in the calculation of current in this branch. What is the first step? Remove the load resistance and short its output terminals and then work out. I will write the same. Removing load resistance and shorting output terminals. We get. In this case, we will remove the load resistance and we will short the output terminals, and then I will start working on this particular problem. Now here I am drawing the figure as it is. First, this part. Here is one resistance. This is another resistance. Here is the current source, which is as it is. This is the dependent source, which is as it is again. And these are the output terminals. Here is the point A. And in this particular case, this is the point B. This is the point B. Here, this value is the 4 ohm. This value is the 2 ohm. This current is the IA. This is 50 volt. Is it right? This current is downward, which is 5 amperes. This is plus and minus. This is 10 IA. This is 10 into IA. And we are shorting these terminals. And here we are interested in this current, which is the Norton's current. First, we will find out the Norton's current. Is it right? Now here in this case, if we are interested in the calculation of current in that branch, then I will use the mesh analysis, because again, this is the branch having the zero resistance as well as this voltage source. Again, it becomes very difficult for the calculation. That's why better way I will use the same method. But with this load resistance, this current is IA. This sustained IA. I will give some different names with this short circuit. I will give its name as IA1. Then this will become IA1. Is it right? Then here, for this loop, I will assume its current as IA1 itself, because again, if I am increasing the another unknown, the number of unknowns will increase. यहाँ पे IA1 है, that's why I am assuming its current as IA1. In this case, I will assume its current as I1, and in this particular case, I will assume its current as IN. That is Norton's current. Is it right? This is Norton's current. Now here in this case, if we have marked the currents, then mark the polarity. This will be plus minus, this is plus and minus, here it is plus and minus. Similarly, this will be plus minus and this is downward, then already its terminals are marked. Now we can find out its equation. We are interested in how many equations? 1, 2, 3, and we are interested in the calculation of its current, which is IN, is nothing but the Norton's current. Is it right? Now what I will do, I will apply the KVL for first loop. I will write the same, applying KVL to loop 1. Applying the KVL to loop 1. If we are applying the KVL, that is Kirchhoff's voltage law, to the first loop, how will be the equation? Now look at, if we are starting from this point, we are traveling in the upward direction, we are traveling in the clockwise. Negative to positive, its voltage is a plus 50. Then positive to negative, it is minus 2 into its current, and its current is IA1. Then positive to negative, it is a minus, its resistance is a 4, and its current is IA1 minus I1, and which is equal to 0, because after that there is no element in the circuit. Simplify this equation and name this equation as equation number 1. If we are simplifying this equation, this will be plus 50 minus 2 IA1 minus 4 IA1 minus up minus plus 4 into I1, which is equal to 0. That is the equation. That's right. If we are simplifying this equation further, how are the values? Here, this is IA1 and this is IA1, 4 plus 2, that is 6, means it is minus 6 into, it is IA1, minus 6 IA1, then it is plus 4 I1, which is equal to minus 50, and this is the equation number 1. This is equation 1 for this first loop. Is it right? If we know the equation number 1, then similarly prepare the second equation, that is for the loop 2 and so on. Now next, we are not able to apply the KVL to the loop 2, as well as we are not able to apply the KVL to the loop 3 because current source. And we don't know the voltage across the current source. That's why I will consider this as a super mesh, and we will apply the KVL to the super mesh. Is it right? Applying KVL to super mesh. Super mesh. Otherwise, I can give the names to this figure. This may be the A, B, C. This is D. Already A, B is there. Otherwise, I will rename it A, B, C, D. This is E. This is F. This is G and H. Is it right? And in this case, load is connected between the D and E. Here it is the D and E. This is D and E now. And we will applying the super mesh for B, C, D, E, F, G. B, C, D, E, F, G. For this particular super mesh, we are applying the KVL, then prepare its equation. So, we will apply the super mesh. If we are applying the super mesh and if we are starting from this point, we are traveling in the clockwise direction, positive to negative, which is minus. Its resistance is a 4 and its current is I1 minus IA1, this value. Then we are moving further, positive to negative, it is a minus 10 into IA1. Is it right? Then we are coming back. There is no element which is equal to 0. This is the equation. Though the circuit is looking to be complicated, look at the equations. Look, equations are very simple. If we are simplifying it, it is minus 4I1, minus or minus plus, it is 4 into IA1, minus it is 10 into IA1, which is equal to 0. If we will simplify this equation, how is the equation? I have taken the first term as IA1. Means here also I will take the first term as IA1. Is 4 into IA1 minus. This is IA1. 10 plus 4 means 14. 14 IA1 minus 4 into I1, which is equal to 0, and that is the equation number 2. Is it right? We have the equation from the super mesh. Now from this current source branch, we get what we get from the current source branch. Look at this. 5 amperes is a downward. Now which current is a downward? This I1. Is this 5 amperes is equal to I1 minus this current is upward, is IN. And if I am simplifying this equation in this format, first IA1, then I1, and then IN. I am arranging the terms in that way. Means here, in this case, equation will be I1 minus this IN, which is equal to 5, and this will be the equation number 3. Is it right? Now here in this case, we have the 3 equations and 3 unknowns. We have the 3 equations and 3 unknowns, and we will solve these equations and we will find out the values of the unknowns. I am expecting the answers from your side. How much is the IA1 first? This is IA1, then I1, and how much is the value of IN, and we are interested in IN, which is the Norton's current. I am expecting the answers from your side. I am waiting for your answers. Yes, Rishikesh.
सर इक्वेशन 2 गलत हो गया सर.
ये गलत हो गया? Which one?
हाँ, माइनस IA1 चाहिए, माइनस 4I1.
Where?
14 है सर, माइनस 6 चाहिए 14 की जगह.
14. ये इक्वेशन
2 सर, इक्वेशन 2
यही ना?
हाँ यस सर. माइनस 6 IA1 चाहिए.
minus 6 IA1. It is 10 IA1 and this is 4 IA1 plus है. Okay. Then this value should be how much?
minus 6 IA1.
Minus 6 IA1. Fine. It is minus 6 IA1 minus 4 I1, which is equal to 0. Now it is correct?
Yes, sir.
Yes. Anyone has again any difficulty or any clarification on this calculation? Yeah. Now work out this calculation and find out the value of unknown, which is IA1, I1 and IN. Yes. Anyone? Please raise your hand and just give me the answer. Yes. Raise your hand if you are ready with the calculations and tell me the answers. I1, IA1 and IN. Yes. इतना डिफिकल्ट नहीं है कैलकुलेशन, स्पीड ज्यादा होना चाहिए. You must be ready with the calculations. Yes, Theorem.
IA1 is equal to 4.16.
4.16 amperes. This is 4.16 amperes. Yes. I1
minus 6.25.
minus 6.25 amperes. And IN
minus 11.25.
minus 11.25 amperes is the answer. But always we are taking its modulus value. That's why it will be 11.25 amperes is the Norton's current. Always we are taking the modulus value. Is it right? Now here, if we know the IN, then we are interested in the calculation of RN. Now look at this carefully. How to calculate the IN? Sorry, RN. So here in this case, we have calculated the IN. Now we are interested in the calculation of RN. How is the RN calculation? Here, generally what we will use, RN calculation is same as the RTH calculation. And when we have the dependent sources, what formula we will use? But when circuit has dependent sources, this RN calculation will be VOC upon ISC, this formula. Because same formula we used for RTH calculation when we have the dependent sources. Is it right? So here ISC is nothing but this is same as VTH divided by IN. Because this ISC is nothing but Norton's current and this VOC is nothing but VTH. Means whenever the problem is for the dependent sources, it may be asked by using the Thevenin's theorem or it may be asked by using the Norton's theorem. The procedure will be the same because we have to find out the VOC, we have to find out the ISC. Is it right? Now here we have already calculated this IN in the Norton's theorem. Now we will try to find out this VTH, which is nothing but VOC. Means we will remove the load resistance, we will open circuit the terminals and we will find out the value of its terminal voltage, which is nothing but VDE. That is this voltage, which is the VOC. Now here for the calculation of VOC, we will remove load resistance and we will remove the load resistance and redraw the same circuit. Redraw the same circuit. Now here I will redraw this circuit. Just I will remove the load resistance. In that case, how will be the figure? This will be our figure. The procedure will be the same for each problem. Whatever it may be the problem, in that particular case, the procedure will be the same. We will apply the steps properly. This is D point, and in this particular case, this point is the E point. Just we are removing the load resistance and we are keeping this terminal open. This is plus minus. This is 10 into IA. This is downward, which is 5 amperes. This is 4 ohm. It is 2 ohm. And this current is the IA. And here, this voltage is the 50 volt with plus and minus. Now look at carefully. With this load resistance, we have taken this current IA. Is it right? With this short circuit, I have taken this current as the IA1. I will give some different name because here, in this case, the circuit is open circuit. That's why I will give this name to this current as IA2. Then this will become IA2. And we are interested in the calculation of this voltage. Now look at how we will calculate this voltage. If we are traveling from the E towards D, if we are using this path, we are not able to find out its VOC. We are not able to find out its VOC because we don't know the voltage across the current source. Is it right? That's why we are not able to use this path. Now we have to use this path. Is it right? We have to use another path. Now in place of using this path, I am use this path because your voltage will be the same independent of any path. You can use this path or maybe you can use this path. Again the voltage will be the same. That's why I will try to find out the current in this branch. Is it right? For that, again, I will use the similar method. Here, in this case, its current name, I will give it as IA2. And in this case, I will give some another name. Because in the previous case, what are the names I have given? The name should not be repeated. Because it will create unnecessary confusion. I have used IA1, I1 and IN. In place of I1, I will take it as I2. Is it right? This is IA2 and I will use this current as I2. Is it right? Now use any method. Now here I can use the direct inspection method or I can use the nodal analysis. This is the node 1, this is one branch, this is the second branch and this is the third. Otherwise I will use the mesh analysis. This is loop 1, this is loop 2. In this case I2 is directly 5 amperes because this branch is not the common. Better way I will use the mesh analysis here. Now applying the KVL to the loop 1. Applying KVL to the loop 1. Applying this KVL to loop 1. You can use the nodal analysis also. If we are applying the KVL to this loop 1, if we are starting from this point, we are traveling in the clockwise direction, negative to positive plus. Its voltage is 50. Then here it is plus and minus. This is plus and minus again. For loop 2, this will be plus and minus. If we are traveling forward, positive to negative, that is a minus, 2 into IA2 will be its potential. Then we are coming down, positive to negative, that is a minus. Its resistance is a 4 and its current will be IA2 minus it is I2, which is equal to 0. That is the equation. Otherwise, we can use the nodal analysis also. ये node होता, ये दूसरा node होता, this is one branch, second branch, and this will be the third branch. यहाँ पे एक equation आता, एक ही unknown होता. That will be the more simple, but I'm using this method. Here it is a 50 minus 2 into IA2 minus 4 into IA2, then plus 4 into I2, which is equal to 0. This is the equation. Now, how is the final equation? This is 4 and this is 2, that is 6. It's minus 6 IA2, is it right? Plus 4 I2, which is equal to minus 50, and this is the equation number 3, I guess. Now we have the third equation. Is it right? Similarly, from loop 2, what we will get from this loop 2? From this loop number 2, directly we get this equation, that is I2 is equal to 5 amperes. This is the equation number 4. Use any method, use a calculator or substitute this value here and find out the values of the currents, that is IA2 and I2. Use any method. because I'm leaving the calculation on you. You can use the matrix equation. This is IA1 is -6, this is +4, this is 50. IA1 0, this I2 will be the 1 and constant will be the 5 in that way. Otherwise, you can substitute this value of the I2 in this equation. 6 IA2 and this 4 into I2 minus 50. IA2 is unknown. You can find out the value of IA2. And here I2 is a 5 amperes. Already we know. Find out the IA2. I'm waiting the answers from your side. Yes. Anyone? I'm expecting some new students to answer. अभी तक जो कभी बोलते ही नहीं क्लास में. One is Sheikh Naushad. I will unmute you. Are you able to give the answers for IA2? Naushad. Are you able to hear me?
Yes, sir.
You need to be interactive, बेटा. थोड़ा सा कैलकुलेशन करना पड़ेगा, इंटरैक्शन होना पड़ेगा, क्योंकि जब तक आप टीचर से इंटरैक्शन नहीं करोगे, आई डोंट नो योर लेवल. इज इट राइट? तो जितना आप पार्टिसिपेट करते हो, मुझे भी लगता है कि अरे ये बच्चा बहुत होशियार है, राइट? इसलिए आपको आंसर्स देने हैं, आपको पार्टिसिपेट करना है, राइट? अगर ये अभी का आंसर नहीं है तो अगले वाले में ट्राई कर लेना. या एनीवन अगेन हैज द आंसर? यस, अविनाश.
11.6.
11 point? Yes, 11.66 amperes is the IA2. If 11.66 is the IA2, I will check with someone again. किसी के पास आंसर है?
Sir, correct है.
Correct है. Okay. So here, if we know this currents, then we will find out its VOC. How will be the VOC? That is open circuit voltage. Now here, in this case, this VOC is equal to, or this is same as VTH. This is equal to, I will travel from the E towards D. You can use any path. If I am using this path, I am traveling from positive to negative. It is a modulus value. I am traveling from E to D, positive to negative, that is minus 4 into its current. How much is the current? This is common branch. If I am following the sign conventions of I2, the resultant current must be I2 minus IA2. Is it right? Then we are coming back positive to negative, which is minus 10 into IA2 is the value, which is equal to, this is modulus minus 4 into IA2. How much is the IA2? 11.66. Sorry, I2 is a 5. Is 5 minus 11.66. This value. Then minus 10 into IA2. And how much is the IA2? It is 11.66. Work out this calculation and find out the VOC. Find out the VOC. Yes. Anyone has the answer? Work out these calculations and find out the values fastly. Shailesh, Ruchira, ऋषिकेश, चिन्मय भी कभी बोलता नहीं. चिन्मय, थोड़ा ध्यान देना पड़ेगा. You have to increase your interaction. Yes. किसके पास आंसर है? Please raise your hand.
Sir, 89.96.
89.96. 89.96 volt is the value of VOC. Now, if we the VOC and ISC, we will find out the RN directly. This RN is equal to, what is the formula? VOC upon ISC, which is equal to, how much is the VOC? Which is 89.96 volt is the VOC divided by ISC. How much is the ISC here? We have already calculated. ISC is nothing but IN, which is 11.25. Is it right? It is 11.25. Work out this calculation and find out the RN, which is the Norton's equivalent resistance. इस क्लास में आई एम यस हाउ मच
7.99.
7.99 ohm is the value of Rn. Yes, Avinash. Correct?
Correct, sir.
Okay, fine. And in this particular class, I am expecting the one answer at least from Chinmay or maybe from Sheikh Naushad. I am expecting minimum one answer in this class. Yes. Now this is Rn. Now here, if we know the In and Rn, if we know In and Rn, then complicated network is replaced by Norton's equivalent network. Norton's complicated network is replaced by Norton's equivalent network. This is right. How is the Norton's equivalent network? This figure is the Norton's equivalent network. This is A point, this is B point, and here we will reconnect the load resistance which is removed in the first step. This Rn is 7.99. This is 7.99 ohm. And how much is this In? This In is, that is 11.25. This is 11.25 amperes is that value. And how much is the load resistance which we have removed in the first step? 10 ohm. And we are interested in the calculation of current in 10 ohm. Now here, in this case, this is 10 ohm. And we are interested in load current, that is IL is equal to In into Rn. This is 11.25 into Rn is 7.99. 7.99 divided by its resistance, that is Rn plus RL. This here it is 7.99 plus 10 will be the value. This is 7.99 divided by 10. Find out its load current. Yes, Ruchira.
4.99.
4.99 amperes. This is 4.99 amperes is the load current flowing through the load resistance using this theorem, which is nothing but the Norton's theorem.